All right, let's take a look at section 3.4, solving quadratic equations by factoring. So again, I have factoring videos if you need to refresh on how we factor. But we'll look at 5 problems here. So, factoring trinomials, in our previous section, we were just factoring. There was no equals 0. Now, if we are equal to 0, we have an equation that we have to solve. If x is squared, you can expect to have 2 answers, unless we're talking about multiplicity or something. But right here, we'll get 2 answers. If we have a minus sign, we are looking for 1 positive and 1 negative factor of 18. We want to choose factors of 18 with a difference of 7. So that's minus 7 plus 2. And x times x is our first terms to get the x squared. So negative 9x plus 2x is negative 7x. And these are the factors set equal to 0. So again, previously, we would stop here, but our answers are not positive 2 and negative 9. Once we get our 2 factors, what we have in parentheses, we set each factor that contains a variable equal to 0. Subtract 2 from both sides over here. And then for x minus 9, we add 9 to both sides. And those are the 2 answers. And if you're an Alex, you just need to look at how they want the answer. Sometimes it's an answer field, and then you have these braces provided on the outside. So we just do negative 2, comma 9. Let's get into a more challenging one. Let's take 8x squared plus 3x equals 5. So in order to solve a quadratic equation, you must be set equal to 0. So I need to subtract 5 from both sides. So the 5 becomes negative as it moves over to the left side. We are set equal to 0, so now we can solve. Now you could use the quadratic formula. If you do, the radical will go away entirely. You'll end up with a perfect square under the radical because this one is factorable. So we will take a look at factoring this. I make my x chart for our a times c. We'll have our b value, and then the 2 factors of 8 times negative 5 that combine into positive 3. That is how we will split the middle terms, or the middle term of 3x. So factors of negative 40 that have a difference of 3 would be a positive 8 and a negative 5. So again, that's how we can split the middle term. I like to point out that you can look ahead and see how you want to factor. It doesn't matter which order we put this in. We can say negative 5x plus 8x, or we can say positive 8x minus 5x. Carry down this minus 5, and the equals 0. So this pair will factor nicely, as will this one. We split down the middle. I can factor out an 8x. Take this off to the side if you need to, but 8x squared divided by 8x is just x. 8x divided by itself is 1. Anything divided by itself is 1. We carry down this sign, and then out of 5x minus 5, we factor out a negative 5. So that becomes x. Negative 5 divided by negative 5 is positive 1. So we take our two factors, put them together as a binomial. The x plus 1 we write once. And now we just solve to get x by itself. Set each factor equal to 0. Over here it's obviously just negative 1. If it's a binomial, you might want to write it out. Add 5 to both sides so that 8x equals 5, and then divide the 8. As a solution set, and again, sometimes you just have to click there's a solution set button. Make sure to separate them with a comma, and there we have it. 3, we'll look at this one. We'll go kind of quickly through it. Something like 10u squared equals 13u. If I subtract this 13u, we have everything on one side of the equal sign. And now, these are not like terms. We don't try to combine them. We look for how we can factor. So out of 10u squared and 13u, I can factor out a u, leaving us with 10u minus 13 equals 0. Anytime your GCF is a monomial, like even if it has a coefficient, you set each factor containing a variable equal to 0. So u equals 0, we're done. But over here, we do a little bit of work. Again, it's the two factors, the u times this binomial, 10u minus 13. Add 13 to both sides, and divide by 10. So that's our solution set, 0 and 13 tenths. Again, in ALEKS, put fractions unless it is asking for a decimal. Here's the problem students probably want help with. Let's take 8x squared plus 22x equals 6. Again, to solve a quadratic, we must be set equal to 0. So I subtract the 6 from both sides. And now, if you went straight into like 8 times negative 6 as your A times C, you would find factors that would combine into 22, and you would be able to do the factor by grouping. But if you end up with something in the parenthesis like let's see what we might get here. If you end up with something like this as a factor, there is a GCF between 2x and 6. And so if you end up with something like this, you missed the GCF of 2. You really don't have to start all the way over. Just take it out, and then this will be right. So, again, students generally have problems with number 4, and it will look like you worked it out correctly, but 2x plus 6, something like that, would not be a factor. So here we have a GCF of 2. I'm going to divide each term by 2. So we put our GCF out front, and then we have 4x squared plus 11x minus 3 equals 0. So we are going to factor this 4x squared minus 11x minus 3, or plus 11x minus 3. A times c, 4 times negative 3 is negative 12. I'm looking for factors of negative 12 that combine into positive 11. So that's a positive 12 and a negative 1. And again, this is how we split the middle. So the 4x squared carries down. We're going to split 11x into positive 12x minus 1x. I think it's helpful to put the coefficient of 1 if we're factored by grouping. Now, we still are set equal to 0. We do still have this GCF of 2, and we'll talk about it in a second. But let's factor this via grouping. Out of 4x squared plus 12x, I can factor out a 4x, leaving me with x plus 3. We carry down this negative. So if you can't factor anything out of the two terms, you can always factor out a 1. In this case, a negative 1. Leaving us with x plus 3, because we're dividing both of these terms by negative 1. We are still set equal to 0. We do have this GCF. I'll kind of put these brackets. Brackets are the same as parentheses. But as we put together our solution, or our factors that make up the solution, we have the x plus 3 times 4x minus 1, and we do have this 2 out front. We have completely factored this problem. But as we go to set our pieces equal to 0, we really don't care about the 2, because there is no variable. There's nothing to solve for in 2. We're only solving for the factors that contain a variable. So again, if you worked a problem out like this without taking out the GCF, this lined up nicely, your factor would look like this, 2x plus 6. So if you have a GCF in one of your final factors, you could actually just take it out then, and then you see we have the 2 times x plus 3. So we set each factor containing, or each factor containing a variable equal to 0. This is just negative 3. Here we add 1 to both sides and then divide the 4. So one more question here, and then we'll be done with 3.5 or 3.4. You might see something like this. W plus 2 times W minus 1 equals 4. So we have to be set equal to 0 to solve a quadratic, but we also have two binomials on the left side. So we actually have to FOIL this. And then we're set equal to 4. Again, students will FOIL this and then try to factor it again, but right now we're just combining like terms. Negative 1 plus W, negative 1W plus 2W is positive W. And I'm going to subtract this 4 from both sides. So negative 2 minus 4 is negative 6. And we're set equal to 0. So we have to FOIL. We have to move this 4 over. And now we factor this. Factors of negative 6 that combine into positive 1 would be W plus 3 times W minus 2. And now we just set both of these equal to 0. So these are our solutions. Negative 3 and positive 2. So again, we can't just move the 4 over at the beginning. I guess we could, but we have to FOIL and then combine like terms, bring the 4 over, combine it with, in this case, the 2, and then factor our new trinomial. So there's 3.4. Hope that helps. Let me know if you have any questions.